weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
I'm your host, Steve Nesbitt, professor in the Department of Climate, Meteorology, and Atmospheric Sciences here at the University of Illinois, Urbana-Champaign. During the second week of March, powerful storms brought tornadoes across Illinois and Indiana, along with large hail. A supercell thunderstorm moved across northern Illinois and northwestern Indiana, producing tornadoes that killed at least 3 people. And it produced some of the largest hail ever recorded in our state. We'll talk about the giant hail in our second segment. But first, the tornadoes.
Tonight, jaw-dropping video of this monster tornado barreling across an Illinois highway. Part of a deadly tornado outbreak.
Tornado down. It's on the ground.
That ravaged America's midsection overnight, ripping down power lines. Watch again as this power line appears to spark. And just seconds later,
that's a tornado. And this is literally the roof of a gas station that was peeled off by the fury of this preliminarily EF-rated 3 tornado that was on the ground for 90 minutes long from Kankakee, Illinois, which is about 25 miles from where we are at in Lake Village, Indiana. It made its way here, 36 miles in total, the full track of the tornado that went on for 90 minutes. Killing 2 people here in Lake Village, injuring others, and remarkably, no one seriously injured in Kankakee, where neighborhoods are decimated, businesses torn up, vehicles on their sides, and trees uprooted.
According to the National Weather Service, 6 tornadoes were confirmed from the severe thunderstorms that moved through the region on March 10th. The strongest storm tracked more than 100 miles from Pontiac, Illinois, through Kankakee to Knox, Indiana. Here to talk about the storms that brought the tornadoes is Jeff Frame, a professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois. His research focuses on severe thunderstorms and the atmospheric conditions that produce extreme weather. Thanks for joining us, Jeff.
Thanks for having me, Steve. It's great to be back.
So when meteorologists were watching the storm develop, especially the tornado that tore across Kankakee County, it was rated as an EF3. How powerful is an EF3 tornado?
Yeah, the wind speeds on tornadoes are estimated from the damage they cause. And so we'll talk more about damage surveys a bit later. But folks from the National Weather Service went out and surveyed the damage, and they rated the maximum winds in that tornado to be around 150 miles an hour. Now, that's strong enough to take down all the exterior walls on a well-built single-family home and basically possibly destroy the second story if there's a second story. So that's why we tell people to get inside into an interior room on the lowest floor of a sturdy structure, putting as many walls between you and the tornado as possible.
So as the storm was developing, I know there were a lot of chasers out there live streaming this particular one. It was quite photogenic in the beginning. But in terms of what people were looking at the Weather Service, what radar signatures might they have seen that a tornado might have been forming in the storm?
Right. The first thing they look at is a Doppler velocity couplet, that is strong winds moving toward the radar adjacent to strong winds moving away from the radar, because the radar can only sense motion toward or away from it. And if you see that couplet, we call it, that's a very good sign of strong rotation. And there are also other signatures they can look at around the storm, including something called the ZDR arc, implying stronger low-level shear and sorting of the raindrops in part of the storm as well.
Yeah, so it's already been an active start to spring here. We're here in mid-March. I believe that we're up to 25 or 26 tornadoes in Illinois already this year, and I think our normal is 5. We're following a couple of years here of very active tornado activity here in Illinois. I think Illinois has led the country the last 2 years. So given this extreme pattern that we've seen so far, a lot of tornadoes, what atmospheric conditions have kind of set up here this year that has been favorable for the development of a lot of tornadoes in Illinois?
Yeah, so every event is a little bit different, but if we focus on March 10th, The four ingredients we look for severe weather are shear, lift, instability, and moisture, or SLIM for short. And shear is basically how the winds change speed and direction with height, and that's usually pretty strong this time of year. That's not your limiting factor in severe weather. Lift is another one where we can have air coming together along fronts or other boundaries in the atmosphere that can form storms. And then also we can have large-scale lift, air going up less than a mile per hour ahead of or east of a trough or a disturbance in the jet stream. And although we had fronts in place on March 10th, the large-scale lift was a bit of a question mark on that event. Then we look for instability, so warm, moist air near the surface and temperatures decreasing rapidly with height, along with moisture. And moisture was also very high. To give you an idea, on March 10th, Lincoln, Peoria, and Springfield all set record highs for that date. And that air mass in place was a lot more typical of what we'd see during a severe weather event in May instead of mid-March. So fortunately, the lift was a little bit less, or that could have been even worse than it already was.
So was there anything unusual other than the record temperatures that allowed the storm to produce a very long track tornado and what could be characterized as gargantuan hail?
Well, yeah, the atmosphere actually did change quite a bit during the life cycle of the storm. It developed just north of Bloomington as a weak, non-severe thunderstorm, and then intensified as it moved northeast up I-55 toward Pontiac, where it produced a brief tornado and intensified into a supercell. And then it continued tracking northeastward in the general direction of Kankakee. And a lot of chasers who were on the storm, they actually abandoned it. It didn't have much of a wall cloud. It looked a little cold, and it was producing a lot of giant hail, though. Now, Kankakee is where we kind of saw the overlap between these two regimes, where the low-level winds began increasing as we approached sunset about 1 mile above the ground. And that's not unusual to see that. It's called the low-level jet, and it does ramp up toward dark. And that stronger low-level shear becomes much more favorable for tornadoes. Whereas a few hours earlier, the storm produced a brief weak tornado, but in terms of tornado production, that wasn't a significant event. But the hail certainly was. And then as that low-level shear ramped up, well, that also is more unfavorable for the production of large hail. So after the Kankakee tornado, as that storm continued across the border into Indiana, there were a couple reports of quarter-sized hail with it, but the large and gargantuan hail reports really stopped as that storm began producing a few significant tornadoes as it moved eastward toward I-65 in Indiana.
Yeah, so I remember looking at the forecast that morning, and I was actually at a workshop at the National Center for Atmospheric Research in Boulder, and one of the other attendees was Howie Bluestein, a famous professor from University of Oklahoma, and very broadly known in the storm community. He came up to me and he said in his accent, which is very Boston, "Have you seen those photographs up there in Illinois? You guys have got to be getting excited about this." But what was the in terms of the official messages coming out of the Storm Prediction Center? Was there an expectation that this was going to be a truly extreme event?
Yeah, there was some uncertainty going into it as whether we would have enough lift to get storms formed. Now, you mentioned a hodograph. That is a plot or a graph we make that lets us visualize how the winds are changing speed and direction with height in the atmosphere. And if that hodograph ends up being long and very straight, that tends to be favorable for large hail and sometimes giant hail. Whereas if the hodograph is long but very curved down low, that is unfavorable, more unfavorable for hail production and a lot more favorable for the production of tornadoes. So that part of the event, kind of the late afternoon to evening event in between Champaign and Chicago near Kankakee, that certainly hit its ceiling. And then there was another part of the event, another round of storms that was forecast to form more over northwestern Illinois, areas north of Peoria, north of Bloomington, up toward LaSalle, Peru. And those storms did form around sunset as that same low-level jet ramped up and slammed into that cold front that was up there. And that part of the event, fortunately, fell far short of its ceiling. As a lot of those storms merged together in a destructive fashion, we call that destructive interference, storm collisions, and a lot of them were kind of undercut by the cold air north of that front, and that was very cold air. Very sharp front. It was like a 40-degree Fahrenheit temperature swing across the front up there. And those storms, they produced a smattering of some hail reports, some brief and weak tornadoes. But that part of the event, had things gone a little bit differently, there could have been several more significant tornadoes across the state as well.
So you mentioned this thing called a supercell, and you've touched on this before in other episodes, but what is a supercell, and how does it differ from a regular thunderstorm that we might have on a typical summer day?
Right. So there are three types of thunderstorms that we see. We have our ordinary thunderstorms, right, your typical summertime thunderstorms. They form, they go up, they make some rain, maybe some small hail, maybe some gusty winds, and about an hour later, they just rain themselves out and collapse. Then we have lines of storms that are capable of producing sometimes extensive strong winds, and also a few tornadoes, occasionally hail. And then there are supercells. And supercells really aren't all that big. They're only about maybe 20 or 30 miles across, although the size does vary a little bit. But what sets the supercell apart is the entire updraft, that rising current of warm, moist air that feeds the thunderstorm. The entire updraft rotates. And so given the rotation already present in the storm, obviously, it's a lot more favorable for those to produce tornadoes. And also that rotating updraft also is more favorable for the formation of large hail as well. In nearly all hail, golf ball sized or larger, that we see in the United States comes from supercells, as long as nearly all significant EF2 or greater tornadoes. And that was a supercell that formed near Pontiac, tracked across Kankakee. In extreme cases, supercells have been seen to last something like 10 hours, but most of them only last maybe 2, 3, 4 hours, something like that, before they either dissipate or merge with other storms and become a line or something.
You're listening to Weather Realness, the weekly podcast about climate and weather. We're talking about the tornadoes that ripped through Illinois and Indiana in March 2026. What are your questions about tornadoes and severe weather? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu. And Illinois' top scientists will answer them on an upcoming episode of Weather Realness. So last week we had a strong cyclone that tracked up into the upper Mississippi Valley and into the Great Lakes. Not unusual for this time of year, but sometimes these cyclones can cause what we call tornado outbreaks, where you oftentimes in the warm sector of the storm, you get multiple supercells that form. So how do tornado outbreaks occur?
Tornado outbreaks, well, we talked about those ingredients: shear, lift, instability, and moisture. And so the shear is going to be there owing to the strong jet stream coming on out. There'll usually be a pretty strong trough in the jet stream back to the west, and ahead of that, we have a lot of lift. Usually there's going to be a pretty strong area of low pressure at the surface with warm and cold fronts and maybe other boundaries to trigger storms. And we'll have warm, moist air flowing northward from the Gulf of Mexico. And with a large drop in temperature with height, that fuels a lot of instability, and like I mentioned, the moisture would be there as well. So if we think back to the environment we had in place, the warm, moist air we had in place on March 10th, and if we were to couple that with the jet stream disturbance that we saw on Sunday, March 15th, that produced a line of storms across the area, a completely different evolution there, but if we were to couple those together, that's how you get a tornado outbreak. And something similar to that happened here back on March 31st, 2023, which prompted the Storm Prediction Center to issue a very rare high risk here in Illinois. And there were dozens of tornadoes reported that day, both embedded within lines of storms near Chicago and actually in EF3 down in Robinson, Illinois, which is about an hour southeast of Champaign-Urbana.
Yes, I mean, we've seen many of these in springtime, the 1974 outbreak.
2011 across parts of the southeast.
Yeah, and even 2024, there was a significant outbreak as well.
Right. And, as bad as March 10th was, and we'll talk a little bit about March 15th in a bit, were these huge severe weather outbreaks, huge tornado outbreaks? No, they weren't. But if you were impacted by these storms, that was probably the worst thunderstorm you've ever experienced. And so those impacts can be very, very highly localized, and we have to keep that in mind, that a bad storm on one side of town can sometimes be not so bad 5 or 10 miles away.
Yeah, so sometimes when we get supercells, the storms produce tornadoes over relatively short distances. But in this case, despite there not being a huge number of tornadoes, there were some that persisted over a large distance. Is there some factor that people consider to look out for long-track tornadoes?
Yeah, there are really a couple things we look at here. Number one is just how fast the storm is moving, which is really governed by how fast the winds are in the mid part of the atmosphere. If those winds are really, really fast, well, the storm's going to get blown along and move really, really fast. So if you have a tornado that lasts for, say, 30 minutes, and that storm's moving 60 miles an hour, well, that tornado path is now going to be 30 miles long. But if you have that same storm maybe in the summer, it's moving a lot slower. I've seen tornadoes last for almost an hour, and they move maybe just a few miles, or sometimes they're stationary for like 5 or 10 minutes. And so those tornadoes just aren't going to be able to move as far because they're not moving as fast. And it also turns out that when we have these fast-moving storms, that means we have a lot of wind shear in the atmosphere, and that does tend to be a little more favorable for supercell and tornado production.
Today, people are still recovering from these storms. I'm sure there's going to be a lot of cleanup in places like Kankakee.
Cheryl, well, everywhere you turn, there are piles of debris in front of homes. And the last 24 hours, neighbors here, they've been focusing on cleaning and rebuilding. As you mentioned, Governor J.B. Pritzker, he was here at Aroma Park to take a close look at some of the damage.
Of course, we focus on the Weather Service in their role in issuing alerts, but also they have a big role after the storm as well. Can you talk about what they do after an event happens?
Yeah, they'll go out and survey the damage. And that means, for example, let's say, there's some trees down on your property, and you want to say, well, is this high winds or is it a tornado? Because high winds and thunderstorms can be of the same strength as those associated with weaker tornadoes, and both can cause damage. And so the Weather Service will send meteorologists out into the field to do what's called a damage survey. And they'll look at things like what were the winds necessary to cause this kind of damage. They'll look at how the damage or how the trees or other things fell over. If all the trees are blown down in the same direction, that's a very good indicator that those were straight line winds all blowing in the same direction out of a thunderstorm that caused the damage. However, if a lot of that damage and debris is blown down in different directions, well, that says that whatever caused that damage was likely rotating winds, which would be associated more with a tornado. So they're able to confirm whether or not a tornado happened. They'll look at the path length of the tornado, where it began and where it ended. They'll look and see as well what the intensity of that tornado might be. Now, for large hail, they don't really survey that as much because the hail, unless you pick it up and put it in the freezer, it's just going to melt. But there were some residents up in Kankakee who were able to preserve some of those very large hailstones that fell back on the 10th of March.
So specifically, how do they determine the intensity? Obviously, they're not out there with a wind sensor during the event.
Right.
How do they relate what they see to an estimated wind speed?
So there's something called the Enhanced Fujita Scale that was put together by both meteorologists and engineers. And this replaced the original Fujita Scale, I believe, in 2006 or 2007, whereas the original F scale was more of an educated guess by Dr. Ted Fujita, who taught at the University of Chicago, by the way. Whereas this one, they actually put, for example, a reinforced brick wall in a wind tunnel and shot a 2x4 at it and said, okay, how strong do the winds have to be to blow a 2x4 through a brick wall or a reinforced concrete masonry wall or some of these other things, or remove a well-anchored roof from a house? And not only looking at houses, but also looking at mobile homes, schools, big box stores, auditoriums, gymnasiums, large span roofs, things like that. And so they have, these damage indicators, and they go out and see what does the damage look like? How does it compare with these damage indicators we have, where we have these estimates of the wind speeds, and they match that up. And whatever the strongest or the worst damage is, the strongest winds they find, that's the intensity of the tornado. Now, most structures damaged, fortunately, do not receive the maximum damage, But if one structure gets an EF3 damage, for example, that entire tornado is rated EF3.
On Sunday, March 15th, we had round 2 of severe weather for this week. The National Weather Service issued several tornado warnings, and one of these warnings included much of Champaign-Urbana. Several reports of strong wind gusts have been received, and the NWS has confirmed 8 tornadoes, all of which were rated EF0 or EF1. We're joined by Jeff Frame, professor with the Department of Climate, Meteorology, and Atmospheric Sciences, and a tornado expert. Jeff, how did the tornadoes that affected Christian, Douglas, and Moultrie counties here in central Illinois compare to the storms in northern Illinois and northwest Indiana that happened back on March 10th?
Yeah, this event was actually quite a bit different meteorologically than the event back on March 10th. The big difference was this was a line of storms that formed along a cold front, whereas back on March 10th, those were predominantly supercell thunderstorms, at least that produced most of the tornadoes and certainly all of the large hail. On March 15th, the shear was actually quite a bit stronger. The lift was quite a bit stronger, but both the instability and the moisture were quite a bit more meager. And so that warm sector air was a lot more characteristic of what we tend to see with severe weather events in mid-March, with kind of weak thermodynamics, we call it, weak amounts of instability, but very strong shear that can do two things. Number one, allow storms to rotate and even get rotating elements within the lines of storms that can produce tornadoes. And also, if you have real strong winds, it's just a lot easier for those storms to bring those winds down to the surface. If there are 60-mile-an-hour winds a mile above the ground, well, that storm doesn't actually have to accelerate those winds at all. All it has to do is transport it down 1 mile, and all of a sudden you have a 60-mile-an-hour wind gust at the ground that can blow over trees and cause other kinds of damage. Also on March 15th, because of the low instability and the forecast line of storms, we weren't expecting much in the way of large hail at all, but it was really a wind and a tornado threat with that. And these tornadoes, when I woke up Monday morning, there was one tornado that had been confirmed across the entire United States. This morning I woke up, and there are probably some duplicates in here, but as of this morning there were 38 from March 15th. And these tornadoes, a lot of them occurred around or just after dark, which limits visibility. A lot of them were completely wrapped in rain in that line of storms, and they were also embedded within a larger area of strong winds. So instead of just saying, oh, well, that tree blew down, it had to be a tornado, what the Weather Service does is they go out and they'll survey and say, okay, was this strong straight line winds or was this a tornado that caused this damage? And so a lot of times with these more linear events, we'll see the tornado reports really fill in the few days afterwards. And there may be even a couple more that are added in the coming days after we tape this.
So obviously, since this event, we had a big transition. Can you explain why we had such a sharp decline in temperatures with that event?
Yeah, well, those storms formed along a very strong cold front, which is the leading edge of a cold air mass. And also, I mentioned that the lift or the dynamics with Sunday's event was a lot more impressive than that we saw back on March 10th. So the surface low pressure system was much stronger. The pressure in the center of that was much lower. And so what that does is it generates a much stronger circulation around that area of low pressure. And we're not talking about a tornado circulation here. We're talking about a circulation much, much larger, hundreds or 1,000 plus miles across. And what this circulation was able to do is bring down a lot of very cold air that was sitting up over south central Canada, into the north central United States, the Dakotas, Minnesota, places like that. And that cold air came on down, and yeah, Monday and Tuesday, March 16th, March 17th, St. Patrick's Day, very brutal cold temperatures.
So when we look back at the past decades of severe weather here in the Midwest, have we seen an increase in tornadoes in Illinois?
Well, the number of tornadoes reported has certainly gone up, and it's gone up significantly since we first started keeping records back in 1950. And the overwhelming reason for this is just the change in reporting practices. For example, on March 10th, you could just bring up YouTube and you could watch, one of 10 different storm chasers out there live streaming their chase in the tornado and the wall cloud or whatever they happen to be seeing out their windshield. Everybody now has an internet-connected camera in their pocket. Whereas if the same storm had occurred, 40 years ago in the mid-1980s, there would have been few, if any, storm chasers on the storm. They couldn't just instantly report what was going on to the National Weather Service. We didn't have Doppler radar. So, for example, a lot of the tornadoes on Sunday would have probably gone unsurveyed and just racked up as wind damage. So we have much better detection technology and much better reporting technology now than we have decades in the past. Now, in terms of the changing climate, there's been some research that maybe Tornado Alley is shifting a little bit east here into the Midwest a little bit. And certainly, Illinois having a lot of tornadoes in 2023, 24, and 25. But still, that's only 3 years. So we got to be careful in assessing any trends that we're looking at a long enough period of record for that to happen. For example, the United States went through a pretty big tornado drought in 2012, 2013, and 2014. And, some people were asking, is climate change going to make tornadoes extinct? And, well, we don't think that's happening either. We think the overall number will stay about the same. We think maybe more tornadoes kind of in your off season, in your February, March, times like that. And maybe fewer tornadoes kind of June, July into the muggy summer months as wind shear decreases a little bit.
So looking ahead, we are in severe weather season here in Illinois. What is our outlook here for the coming days?
Yeah, for the coming days is that cold front, that same strong cold front that brought all the cold air in. Well, it swept all the way down into the Gulf of Mexico and basically cleared out all that moisture. And again, without moisture, you're just not going to have instability. So we're not looking at any widespread severe weather outbreaks really anywhere in the country over the next week or so. And then our jet stream pattern also going to be fairly unfavorable with a big ridge and actually, summer-like temperatures, record-breaking heat out west. And so as we go forward toward the end of March, any kind of widespread severe weather looks pretty unlikely, not only here in the Midwest, but really over the entire United States. So we get a bit of a break.
Well, thank you for joining us, Jeff.
Thanks for having me, Steve. It's always good to be here.
I'm Steve Nesbitt. We're talking with Jeff Frame, a professor in the Department of Climate Meteorology and Atmospheric Sciences at the University of Illinois. What are your questions about tornadoes or severe weather? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu. And Illinois' top scientists will answer them on an upcoming episode of Weather Realness. Coming up next, we'll talk about how recent storms in Illinois produced a record-sized hailstone. Could we expect more dangerous chunks of ice coming from the sky? Weather Realness returns after this.